In this question, different covalent compounds are given in list 1 and their geometries are given in list 2. We have to match the list 1 with list 2. Let's move to the compounds one by one. First of all, let's write BrF5. Here bromine is the central atom and it has 7 electrons in their valence shell. When they are surrounded by 5 fluorine atoms, one electron pair will be remaining non-bonded and other all electrons will be used to make 5 covalent bonds. So here, due to the lone pair bond pair repulsion, the geometry will be square pyramidal. Here nitrogen has 5 electrons in their last shell. Among the 5, 3 will be utilized to make 3 bonds with 3 hydrogen atoms. And due to the lone pair bond pair repulsion, the geometry will be trigonal pyramidal. And the third one is XeF4. Here Z is the noble gas with 8 electrons in their last shell. Among the 8 electrons, 4 will be utilized to make 4 covalent bonds with fluorine atoms. And 2 electron pairs will remaining unbonded. And 2 electrons will remaining non-bonded and they are called 2 lone pair of electrons. Due to the lone pair and lone pair bond pair repulsions, the geometry is square planar. And the last one is SF6. Here sulfur has 6 electrons in the last shell. All the 6 electrons are utilized to make bonds with fluorine atoms. And the geometry is octahedral because there is no any lone pairs. So bond pair repulsion is giving the octahedral geometry. So from these options we could see that option C is the correct one.